In this video, I want to try to show you the difference between what would be considered a normal distribution problem and then what would be considered a problem that involves the central limit theorem, because you will have to make that determination on the midterm exam. But also, some of you seem to be struggling dealing with the problems related to the central limit theorem, so I'm going to work through some examples. So I have two questions or two scenarios here on the screen. So let's kind of look at the two of them and look at the differences so that you can learn how to tell the difference. The first one reads, the cost of unleaded gasoline in the metro Atlanta area once followed a normal distribution with a mean of $2.98 and a standard deviation of 45 cents. One gas station from the metro Atlanta area is randomly chosen. We are interested in the average cost of gasoline for that one gas station. Okay, so couple of things about this particular question, and I do have a grammar mistake there, I apologize. Okay, is that one, it tells us in the description as you're reading the problem that it is a normal distribution. Furthermore, it tells us the mean and it tells us the standard deviation. So guys, that's one thing when you're looking at a normal distribution problem, you have to be told those three things. Okay, so you have to be told when you're looking at a normal distribution problem, you have to be told that it's normally distributed in some way, however it's phrased. You have to be told the mean, and you have to be told the standard deviation. If you don't know those three things, you cannot work through the problem. The other piece that's here that kind of lets me know this is just a basic normal distribution problem is that it indicates that we're going to select one gas station, or it could say a gas station. Okay, but that's the other clue that I'm just going to do the basic normal distribution process in Minitab to answer the question. Now, if we look at the second one and begin to read through it, it says the cost of unleaded gasoline in the metro Atlanta area once followed an unknown distribution with a mean of $2.98 and a standard deviation of 45 cents. 25 gas stations from the metro Atlanta area are randomly chosen. We are interested in the average cost of gasoline for the 25 stations. So a couple of things that are different. We start out knowing here that this is an unknown distribution. It doesn't indicate to us that it is normal. It still gives us the standard deviation, and it still gives us the mean of the distribution. The other piece that is different is it tells us that we're going to select 25 gas stations. And that's kind of my clue that I'm possibly going to use the central limit theorem. Typically, when we want to apply the central limit theorem, you're going to be selecting a group of items as opposed to a single item or one as is indicated in the question above. So that's one clue that I'm going to use the central limit theorem. The other is that we have an unknown distribution. But if you go back and look, one of the consequences or one of the results of the central limit theorem is that we can have an unknown distribution. And if we take a sample that is large enough, and that depends, large enough, then that distribution is forced or becomes normal. So because we're selecting 25, our sample size is 25. Again, that's a clue. They tell me that my mean for my sample is $2.98 and that my standard deviation is 45 cents. But then we have to apply the central limit theorem. So the first question that you see kind of in the problem set here asks you what is the mean for this problem. Well, even though we've realized we need to apply the central limit theorem, another consequence of the central limit theorem is that the mean of the sample for the single is the same as it is for the group. Remember, we indicate the group with a little subscript of x bar. So the mean of the sample is the same as the mean of the sampling distribution. That's how you say it. Okay, so in this problem, that means my mean is still $2.98. The mean is the same. Again, that's a consequence of the central limit theorem. The second question asks you what is the standard deviation you will use for this problem when looking at the average of 25 gas stations, and it asks you to round it to 2 decimal places. So here again, you have to remember there's a slight difference in the standard deviation. The standard deviation of the sampling distribution is the standard deviation of the sample divided by the square root of your sample size. That we have to adjust the standard deviation when we apply the central limit theorem. And typically the standard deviation for a group is going to be smaller than the standard deviation of an individual. So in this case, I would have the standard deviation of the sampling distribution would be the original sample standard deviation, which is 45 cents, divided by the square root of our sample size, which is 25. So we have 0.45 divided by 5, which is 0.09. This is the value for the standard deviation that I need to use whenever I begin to calculate my problems. So let's get into how to do that, and we are going to be using Minitab, so I'll have to be toggling back and forth. Okay, but the first question says, what is the probability that 25 stations will have an average price less than $2.99, and round your answer to 4 places. Now, I personally like to draw a picture. I know that since we're applying the central limit theorem, that my distribution, although it was originally unknown, is going to follow a normal distribution. I know that the mean is going to be $2.98 because the mean of the sample is equal to the mean of the sampling distribution. Then it tells me we want to know the probability that it is less than $2.99. So common sense tells me that $2.99, and I'm going to write it up here on the top, would be slightly to the right of the mean, and I want to be less than that. So what I'm actually looking for from a visual perspective is I'm looking for this red shaded region. But now remember that when you go to use Minitab here, you're going to use the fact that the mean of the sampling distribution is $2.98 and that the standard deviation is the 9 cents. You have to use the adjusted standard deviation. We still use a normal distribution. So I'm going out to Minitab. We go graph, and we scroll down to probability distribution plot. Then we want to view the probability. I click OK. I am using a normal distribution. The mean that's given to me is $2.98. The value for the adjusted standard deviation under the central limit theorem is 9 cents. We choose options. We're defining the area by a specified X value, and it is a left tail because it is less than, and my point of interest is $2.99. I click OK, and I click OK. So then when I look at this plot, okay, my numbers are kind of jumbled here on the number line, but I can see my red shaded region, and it is 0.5442. So according to Minitab, this red shaded region that I drew in by hand is 0.5442. So again, what that means in this context, to try to help you understand what that means, it means that there is about a 54% chance that the average price will be less than $22.99 for those 25 stations. Again, there's about a 54% chance that the average price will be less than $2.99 for those 25 stations. All right, let's look at another one. I'm going to work above this one here. It says, what is the probability that 25 stations will have an average price between $2.88 and $3.08? Again, we're looking at the 25 stations. So again, that's my clue that I'm going to apply the central limit theorem. So if I draw a picture here, I have, again, even though we're told it's unknown, when we apply the central limit theorem, it's going to mimic the normal distribution. My mean is $2.98. In this case, I want to consider if my gasoline price is between $2.88 and $3.08, and I want to be between. So I'm looking for this red shaded region between those two numbers. In Minitab, they call this the middle. Okay, again, since I'm applying the central limit theorem, I have to use the mean of the sampling distribution, which is $2.98. I have to use the standard deviation of the sampling distribution, which again is the adjusted standard deviation, which is 9 cents. Going back out to Minitab. Again, it's graph, probability distribution plot, view probability, click OK. It is a normal distribution. It's $2.98 is my mean, 9 cents is my standard deviation. I am using a specified X value. I'm in the middle, and I'm between $2.88 and $3.08. Guys, when you enter these X1, X2 values, make sure you enter the lowest value first and the highest value second. You always read your graph left to right. I click OK. I click OK. And again, I get the graph that shows, and I get 0.7335. Okay, notice it up here at the top. Okay, so this red shaded region, based on the results from Minitab, is 0.7335. So there is approximately a 73% chance that the average price of unleaded gasoline will be between $2.88 and $3.08. Okay, then let's look at this last one. It says, what is the probability that 25 gas stations have an average price less than $2.75 or greater than $3.05? And I picked this example because this is a special case. So I want to make sure you understand how to do it. Okay, so we have our horizontal number line. Again, it's going to be a normal distribution. The mean is $2.98. We want to be less than $2.75. So 275 would be somewhere on the left, and less than is to the left. Then the other option is or, so you have an or, greater than 305. Okay, this one's a little tricky because Minitab won't let you calculate it directly. It is a special case. So what we do in Minitab is we have to basically calculate the middle. We're going to look at it's kind of like eating the middle out of the brownies. Okay, we're going to figure this region here and then subtract from 1. So let me make you a couple of notes here. This is a special case. It's a special case even with the normal distribution. Okay, we have to do 1 minus the middle. But again, we've applied the central limit theorem. So applying the central limit theorem, my mean of the sampling distribution is $2.98. My standard deviation for the sampling distribution is the 9 cents. So when I say middle, we're going to go from, take out that yellow highlight, from $2.75 to 305. Okay, that's kind of the middle piece. So I'm going to go out to Minitab, graph, probability distribution plot, view probability. Okay, it's normal, mean of $2.98, standard deviation of 9 cents. I am going to calculate the middle between $2.75 and $3.05. Okay, and we get that red shaded region is 0.7763. Okay, so that tells me that this red, or my yellow highlighted region here, is, and I forgot what it was, 0.7763. So this red shaded region is 0.7763. So I've eaten about 78% of the middle of the brownies. So I have 1 minus 0.7763. I'm going to get my calculator and do that on my handheld calculator. 1 minus 0.7763 gives me 0.2237. And that value of 0.2237 encompasses the area to the left and the area to the right. It's Minitab's already kind of combined that together for you. So there's about a 22% chance that the average price will be less than $2.75 or greater than $3.05 for those 25 stations. So I hope that gives you a better sense of how to deal with the problems that involve central limit theorem.